Welcome to this video on power. By the end of this video, you should be able to interpret the power of a significance test and describe what factors affect the power of the test. So we're going to investigate this claim that I had way back when of I'm an 80% free throw shooter. So there's another teacher, Mr. Wilcox, and he is skeptical and he believes that I am less than an 80% free throw shooter. So we've decided to take another SRS of 50 free throws to prove myself. So we're going to write our appropriate hypothesis for the significance test. Be sure to define the parameter of interest because always we do that when we write our hypothesis. So we're going to have the null, because I'm still claiming I am an 80% free throw shooter. The alternative is that I am not. I am less than. Okay, and so what does that mean in words before we define here? Because this will help us when we start talking about our types of errors. So this is my claim. We always assume the claim is true. So we say I am truthful. Or because it's less than, we think I'm exaggerating. That's a nice way of saying I was lying about it. Okay. Now, our parameter here is the true proportion of free throws made by me. All right. So what would a type 2 error in this scenario mean? So remember, a type 2 is a failed to reject the null, meaning we kept the null when the alternative is true. Stop the video and see if you can come up with a type 2 and come back and see how you did. So a type 2 in this setting would be I am less than an 80% free throw shooter, but we found no convincing evidence that I am less than an 80% free throw shooter. Not a serious consequence. It's probably not that big a deal, but that's the type 2 error in the context of this setting. So when we took this SRS of this previously, we had that I was a 66% free throw shooter in our sample. So what if that's true? Okay, what if I actually am a 66% free throw shooter? That would make our null true. We're going to enter the information in this applet. If you want to follow along with the applet, here's how you can get there. So we're going to click the display type 2 error, and it's going to show as a blue shaded region. So here is our app, okay? And so here's what we're going to do. Our null hypothesis was 0.8. So I'm going to drag this up. So that's our null hypothesis. And you can see these graphs over here are changing. We had a less than, so remember two-sided is the not equal to, and then we have less or greater than, and our alternative was less than. So we're going to click less than. We're going to do a type 2 error, so it will show up. So what we do is we have two different things here. This red one, this is my claim. This blue one is, well, what if what we think, what if our p-hat is true is really, and so our p-hat was 66%, 0.66. So I'm going to drag that to 0.66. All right, so what we've got here is the red is what the claim is, and the blue is what the sample is suggesting. We had a sample size of 50, and we had an alpha of 0.05. So this blue area right here, this is the overlap. This is the probability of a type 2 error, because right here at this line to the left where it goes left, that is your area that we got from our alpha. That's actually your 5% area, the probability of a type 1 error right there. So it's where these two different graphs of what the claim is versus what the sample is suggesting, where their overlap is outside of the type 1 error probability, your alpha probability. That's what power is. So it's kind of a hard thing to talk about. But so let's look here, and we have the probability of a type 1 error is 5%, and that 5% is represented right here in this white region right there. Okay, that's what we would have shaded for our area. Now, the probability of a type 2 error, they're calculating for us. We are never going to calculate this. We only have to understand kind of the relationship that goes on. And our power is 76%. So when we look here, we say, if Ha is true, what is the probability of a type 2 error or a bad decision? So they said the probability of a type 2 error was 0.24. Okay, and what is, if the null is true, or sorry, if the alternative is true, what would be the probability of a good decision here? That's our power number that was on the thing. So that's going to be 0.76. Okay, so when we look at these two things together, the probability of a type 2 error plus power will always equal 1. Okay? So to find the probability of a type 2 error, you're going to take 1 minus power, and it will tell you what's left over. Okay? Remember, the probability of a type 1 error is just your alpha. Now they're not direct inverses of each other. They are related to each other. And how they're related is, we have our actual graph here. This is my claim. The blue one is from our sample, suggesting it's something different, and see where the graphs overlap. This line right here, this is where we would have shaded for our significance test when we were finding the area. That's our probability of being wrong. Okay, the rest of it in the overlap, this blue section, that's the probability of a type 2 error. Okay, so now we want to interpret this probability of this good decision in the context of the problem. All right, let's take a look. We're going to go back and add some more notes in, so we'll come back to that in just a second. So if I am a 66% free throw shooter, there is a 0.76 probability that we decide correctly that I was exaggerating. Okay, let's kind of break this down a little bit. So we have our type 2, and we have power. So power is kind of how clearly are you seeing what's going on, what's really happening. How well does your test pick up little tiny differences? Think of it as like a pair of binoculars or a microscope. You can zoom way in and you can pick up minute details, but you kind of miss the bigger picture also because you're too far zoomed in. So your power is how well can you pick up tiny differences in data, and what can it tell you? Like, how important are these differences? So for us to be able to determine power, you must have this alternate number. So that came from our p-hat in this case. You must have a specific alternate value in place. Because we're talking about the overlap between the two graphs of this from this p-hat versus what the claim is, and you're looking for those overlaps in those graphs in order to find your power. So that's what these were. We couldn't have had the blue graph unless I had the specific value of 0.66 from my sample in order to generate it. Okay, so if I actually am a 66% free throw shooter, that's a condition. Okay, so this is a condition right here. So we're kind of talking about a conditional probability here. And what it's saying is the probability of rejecting the null given the alternative is true. Okay, so if this condition, if I actually am a 66% free throw shooter, there is a 0.76 probability that we will decide correctly that I am exaggerating, meaning we will reject the null. Okay, so your power, so 76%, we're gonna be pretty good. So that means we could have made an error in 24% of the situations, and that's where the type 2 error comes in. That's how these two guys are related right here. Okay, so we're never going to calculate power. You're never going to have to overlap your graphs and try and figure all this out. I want you to understand a relationship of what's going on here. Okay, so there's some different things. Let's pull this back up again so we can take a look and see what can happen. So we're going to click the display power. So here's my display power. I'm going to click that, and you see the green showed up. This is my power. Okay, that's the probability of being correct if the alternative is true, that alternative value of the 66% that we got from our sample. Okay, we want to increase the power of our test. How could we adjust each of the following factors to increase our power? So we want the green to be bigger. So if we look at sample size, and I drag the sample size, so it changes the shape, but notice this is like somewhere between 0.6 and 0.7. When it was at the sample size we used of 50, it was at 0.76. So that value went down when the sample size went down. Let's look what happens if we make the sample size bigger. Notice it went further up. So our power here is now 92. Okay, so now we have a 92 power. So when my sample size gets bigger, oh, that's the true value of P. That's not the one we're moving yet. We're just moving our sample size. If I make my sample size bigger, my power gets bigger. Okay, so if we want to increase the power, which is what our question is asking us, we're going to need to increase our sample size. Okay, now what role does alpha have in this? So let's go back and look at that. So I'm going to put this back to our regular sample size that we started with. Okay, so what happens if we want to increase power? What do we need to do with alpha? So we're currently at alpha 0.05, so I'm going to take alpha down and come back here and look at my power. My power is now down to 71% from 76%. If I make alpha more than 0.05, the green, it's a little hard to see. It's easier to look at the number. The power is now 82%. So if we want to increase our power of our test, or our ability to see the smaller differences, we need to increase our alpha. Okay. Now our alternative P, and they're not talking about this value here. They're talking about the specific value that we have to put in, suggested from our P hat in this case. Okay, so our alternative P, let's take a look what's going to happen there. So let me put our error, our alpha back to 0.05. Now, that 0.66 came from a sample where I made 66%, which drove the alternative hypothesis to be less than 0.8. But this specific value, what happens if I make the specific value lower? Whew, look, it shifted all the way over here, and now the entire curve is green. The power went way up when I took my alternate value from my P hat. So if I make my alternate value bigger, it's really difficult to see, but there's a tiny, tiny green section right here. Okay, so if I'm wanting to increase my power, I need to decrease my alternate value of P. There needs to be a bigger difference between them, essentially, is what's talking about. So we would need to decrease our alternate P. Okay, so let's talk about a few things here. So if we increase our sample size, what happens is we decrease variability. We've been talking about that almost all year. Which decreases overlap. Okay. For our alpha level, if you increase alpha, it makes rejecting the null easier. Which will make your type 2 lower, because they kind of have an inverse relationship to each other. Okay, and our alternative P, if we increase the distance from the null, that's making more of a difference. So increasing the distance to the null makes it easier to see the differences, and that's the power. Okay, so that would make the power increase. So to increase power, you would want to increase your sample size, increase your alpha, and increase your distance from the null. Okay, so let's kind of look. I'm going to separate these out, these drawings that we were seeing on the app. So if we had my original claim here, which was at 80%, and then we had an alpha 0.05 and we found our area, and this is our cutoff area right over here. Okay, but we had this specific value, an alternate value given to us, where our sample suggested it was 0.66. Okay, so this is where they overlap right there. So this would be my type 2 error, right here, this overlap from this alternate number. This original that we've been doing all along, this is our type 1 error. Okay? But all of this over here, that's all your power. So if you drag this to increase your alpha, it decreases your type 2, which increases your power. Okay? If I scooch this way, I would be decreasing my type 1, increasing my type 2, but decreasing my power. Okay? So power and type 2 are inverse from each other, and type 1 error and power kind of go together. If you reduce your type 1 error, you reduce your power. Okay, so hopefully we're kind of getting this. This is kind of the easiest thing if you think about this guy sliding back and forth. If we slide him right, this area gets bigger, this area gets smaller, but the green area gets bigger. So type 1 increases, type 2 decreases, power increases. All right, so hopefully that's not too confusing. It's a very tough topic. Let's turn this over and summarize on the back. I just wanted to remind us of the matrix that we talked about previously, where we have these 4 options going on. We can either have our null be true, or we can have our alternative be true. Okay? And the decisions we make from these are we either reject the null or we fail to reject the null. Okay? That's every significance test. Either the null is true or the alternative is true, and we either reject or we fail to reject. That's all there is to it. If our null is true, but we reject it, we've made a mistake. We should have kept it if the null is actually true. That's your type 1 error. If your alternative is true and you rejected the null, that means we got rid of the null to keep the alternative. That's what we want to have happen. That's our happy spot right there. If our null is true and we fail to reject it, fail to reject means we kept the null and the null is true. That's exactly what we want to have happen. And if we have an alternative that's true, but we failed to reject the null, that means we kept the null and we should not have. That's your type 2 error. Okay. Hopefully that's kind of helping you solidify the idea of type 1 and type 2 in your head. Now let's talk about power. Power is your probability to reject the null given the alternative is true. Okay? It's your probability to reject the null given that your alternative is true. Okay, and that's what we were talking about when we said if I actually was a 66% free throw shooter, that's our alternative. That's the probability that we're correctly making our decision here. Okay, so I'm going to give you kind of a little bit of a math lib for interpreting. So if your alternative is true, you got to specify in context. There is a blank, and in that blank you're going to stick whatever your power number is, probability, of finding convincing evidence to reject toe. And you got to make sure that's in context also. Okay, so it's very similar to our other interpretations of these probability numbers. If your alternative is actually true, be very specific with your context. I just talk about the number. There is a whatever the power is probability of finding convincing evidence to reject the null. Okay, so type 1 and type 2 are opposite each other. Okay, let's see. So let's talk about our errors. We got the probability of a type 1 is your alpha. And we have the probability of your type 2 is going to be 1 minus power. Okay, ways to increase power. Increasing power is all related to your alpha. Okay, so to increase power, you could increase your sample size. You could increase your alpha, or you could increase your distance to the null. It's easier to pick up a difference the further away it is, and that's what the whole purpose of power is, being able to see a difference in the data. Okay, I want you to give the Check Your Understanding a try. Check your answers when you're done. Let me know if you have any questions. See you in class.